Welcome to Maths Point. In our last tutorial, we talked about the congruence of triangles and we also saw one of the criterions by which we can say the two triangles are congruent, and that was side angle side congruence criterion. Now in our today's tutorial, we will be talking about one more criteria, and that is angle side angle congruence criterion. Let's see the statement of this congruence criteria. Angle side angle congruence criteria states that two triangles are said to be congruent if two angles and the included side of a triangle are equal to two angles and included side of another triangle. That means we are having two triangles just like here ABC and XYZ. It says that these two triangles will be congruent if two angles of one triangle, for example, two angles of triangle ABC, angle B and angle C, these are equal to two angles of triangle XYZ, that means angle Y, and angle Z. Also, the included side between these two angles, just like here in ABC, it is BC, and here in XYZ, it's YZ. So it says that these two triangles will be congruent if two angles and included side of one triangle are equal to two angles and included side of another triangle. And this statement is in the form of a theorem, so we will prove it. Let's prove it here. So statement is again here. Two triangles are said to be congruent if two angles and included side of one triangle are equal to two angles and included side of another triangle. So we will write the given things here. So let's suppose that two angles, this angle B is equal to angle Y. So in triangle ABC and triangle XYZ, angle B is equal to angle Y. Similarly then, included side BC is equal to YZ, and this angle C is equal to angle Z. So this is our given information here, and we have to prove that the two triangles are congruent. So to prove is triangle ABC is congruent to triangle XYZ. Now, in order to prove that the triangle ABC is congruent to triangle XYZ, we have a result of SAS congruence criteria, which says that two triangles are congruent if two sides and included angle of one triangle are equal to two sides and included angle of another triangle. So here it is given that angle B is equal to angle Y, and then angle C is equal to angle Z. Also it is given that BC is equal to YZ. So we will prove that triangle ABC is congruent to triangle XYZ if we will be able to prove that either AB is equal to XY, or we will be able to prove AC is equal to XZ. So in order to prove this, let's suppose that we will try to prove here that AB is equal to XY. Now since AB and XY are two line segments, so we can compare their lengths. Here, AB and XY are sides of two triangles. That means these are line segments and we can compare their lengths. Then, if we'll compare their lengths, then either AB will be equal to XY or AB is greater than XY or AB is less than XY. These will be the three comparisons between these two sides. So now let's take these three cases one by one and we will see what we'll get here. So let's take the first case as if AB is equal to XY. So our given things are that angle B is equal to angle Y, BC is equal to YZ, and angle C is equal to angle Z. So now let's try to prove it here that if AB is equal to XY, then at that time in triangle ABC and triangle XYZ, we suppose that AB is equal to XY. That's our supposition. Then it's given that angle B is equal to angle Y. Also, it's given that BC is equal to YZ. Therefore, we got here that two sides and included angle of one triangle are equal to two sides and included angle of another triangle. Therefore, by side angle side congruence criteria, we can say that two triangles ABC is congruent to triangle XYZ. And if we will check the corresponding parts from these two triangles and we'll compare them with our given statements, we will get angle B is equal to angle Y, BC is equal to YZ, and angle C is equal to angle Z. That means there is no contradiction with our given statements. Now, let's take case second, in which we will suppose that AB is greater than XY. Since here we are supposing that AB is greater than XY, so we will extend this XY to a point, for example P, such that we will suppose that AB is equal to PY. Let AB is equal to PY as AB is greater than XY. Now let's join this PZ. So we got here two triangles ABC and PYZ. Let's take these two triangles. In triangle ABC and triangle PYZ, we suppose that AB is equal to PY. Then it's given that angle B is equal to angle Y. Also, it's given that BC is equal to YZ. So we got here by side angle side congruence criteria that the two triangles are congruent. So by side angle side congruence criteria, triangle ABC is congruent to triangle PYZ. That means this Angle B is equal to angle Y, which was our given statement. Angle B is equal to angle Y. Then it was also given that BC is equal to YZ, and it was given that angle C, that means angle BCA, is equal to angle YZX. It was, these were the given statements. Now let's try to check what we'll get from the congruence between these two triangles ABC and PYZ. So we got here that angle B is equal to angle Y, then BC is equal to YZ, and then we got that angle BCA is equal to angle YZB. If we'll consider that triangle ABC is congruent to triangle PYZ, but this angle BCA was given as it is equal to angle YZX. So from these two statements, we can say that angle YZP is equal to angle YZX. So it is angle YZX is equal to angle YZP, which is not possible because this angle YZX is part of angle YZP. So it is possible only, which is possible only if P and X coincides. That means this Py should be equal to Xy. Since we suppose that Py is equal to AB, that means it's possible only if AB is equal to xy. So here we suppose that AB is greater than xy, but when we supposed it, we got a wrong statement that angle YZP is equal to YZX, and it is possible only if AB here is equal to xy. That means this second case failed here. Now let's take the case third similarly, which we considered that AB is less than xy. So here we know that we are given that in these two triangles, angle B is equal to angle Y. Then it's also given that BC is equal to YZ, and it's also given that angle C is equal to angle Z. Now we are supposing here that AB is less than xy. That means this time we will reduce the size of xy up to p. So let's suppose AB is equal to py. So let AB is equal to py. So we will take these two triangles in triangle ABC and triangle PYZ. We supposed here that AB is equal to py. That's our supposition. Then it's given that angle B is equal to angle Y, and also it's given that BC is equal to YZ. So these two are given. Therefore, we got here by side angle side that the two triangles are congruent. By side angle side congruence criteria, triangle ABC is congruent to triangle PYZ. That means, again here, this angle BCA is equal to angle YZP. But it's given that angle BCA is equal to angle YZX. x. So from these two statements again, we got that angle YZX is equal to angle YZP. But if you will see it from the figure, we can say that this angle YZP is part of this angle YZX. So these two can't be equal unless AB is equal to XY. That means P and Y should coincide. So which is possible only if X and P coincides. That is XY is equal to PY. Then we can say XY is equal to AB. Thus in all the three cases, we got the correct statements only if AB was equal to XY. Thus we can simply say that these two triangles are congruent if AB is equal to XY. Then we can use the SAS congruence criteria and we can prove that the two triangles ABC and XYZ are congruent. This was proved here that if in two triangles, two angles and included side of one triangle are equal to two angles and included side of another triangle, then the two triangles are congruent. Now we are having one more congruence criteria, and this one is a result obtained from angle side angle congruence criteria, and it is angle side congruence criteria. And the statement of this congruence criteria is two triangles are said to be congruent if two angles and one side of a triangle are equal to two angles and one side of another triangle. In our previous criteria, it was given two angles and included side, but this time it is simply two angles and one side. So it can be non-included side as well. So let's suppose that it is triangle ABC and in triangle XYZ. So let's take the given part. In triangle ABC and triangle XYZ. Let's suppose that angle B is equal to angle Y, as it is said, two angles and a side. So we'll suppose angle B is equal to angle Y, then angle C is equal to angle Z. If we will consider BC is equal to YZ, then we will be in these two triangles will be congruent by angle side angle, and it is proved already. Now let's suppose we will take any side among these two. Let's suppose AB is equal to XY. So these three are our given statements, and we have to prove that triangle ABC is congruent to triangle XYZ. Let's prove it. We know that in triangle ABC, if we will use angle sum property, that is angle A plus angle B plus angle C, it's equal to 180, because we know that sum of interior angles of a triangle is 180. Similarly, if we will take triangle XYZ, again we will use angle sum property. That means angle X plus angle Y plus angle Z is equal to 180 degrees. So in both the statements, in both the equations 1 and 2, angle A plus angle B plus angle C is equal to 180, and in second equation, angle X plus angle Y plus angle Z is equal to 180. And we know that from axiom 1, when two things are equal to the same thing, then they are equal to one another. Therefore, from first and second, we get angle A plus angle B plus angle C is equal to angle X plus angle Y plus angle Z. Now we know that angle B is equal to angle Y. So instead of angle Y, we can write angle B. And we know that angle C is equal to angle Z. So instead of angle Z, we will write angle C. So here angle B and angle B will be cancelled and angle C and angle C will be cancelled. So we got here that angle A is equal to angle X. Now if we will take these two triangles and triangle ABC and triangle XYZ, we proved that angle A is equal to angle X. Angle A is equal to angle X, then AB is equal to XY and angle B is equal to angle Y. Therefore, we got that two angles and included side of one triangle are equal to two angles and included side of another triangle. That means by ASA congruence criteria, triangle ABC is congruent to triangle XYZ. Thus, we proved that if two angles and a side of one triangle are equal to two angles and one side of another triangle, then the two triangles are congruent. So these were some of the congruence criterions that we read so far. The first one was side angle side congruence criteria, in which we said that two triangles are said to be congruent if two sides and included angle of one triangle are equal to two sides and included angle of another triangle. Then we read about another congruence criteria, which was angle side angle congruence criteria. And in this criteria, we read that two triangles are said to be congruent if two angles and included side of one triangle are equal to two angles and included side of another triangle. And the third one we read is angle angle side. That means two triangles are said to be congruent if two angles and a side of one triangle are equal to two angles and a side of another triangle, then the two triangles are congruent. Now let's use these congruence criterions to prove the NCERT exercise of class 9, that is exercise 7.1. So the question number 1 here is in quadrilateral ABCD, so we are having a quadrilateral ABCD here. It is said that AD is equal to AC and AB bisects angle A. That means this AB bisects angle A. So let's suppose that these two angles, angle 1 and angle 2, are here formed. Now we have to prove that triangle ABC is congruent to triangle ABD. So here it's given that ABCD is a quadrilateral, ACBD is a quadrilateral, in which AC is equal to BD. Also, AB bisects angle A. That is, here we named them as angle 1 and angle 2. That's angle 1 is equal to angle 2. Now we have to prove that triangle ABC is congruent to triangle ABD. Let's prove it. So let's take these two triangles, triangle ABD, ABC and triangle ABD, and triangle ABC and triangle ABD. It is given that AC is equal to AD, AC is equal to AD. It's given. Also, it is given that AB bisects angle A, then angle 1 is equal to angle 2. It's also given. And then we will see that this AB is common in both the triangles. So we can say AB is equal to AB, which is common in both these triangles. So we got here by side angle side congruence criteria that triangle ABC is congruent to triangle ABD. Then the question asks us, what can you say about BC and BD? Since BC and BD are corresponding parts of these two triangles, we can say that these corresponding parts are equal. Thus BC is equal to BD, as we know that corresponding parts of congruent triangles are congruent. CP, CT, C. This we proved here that in this quadrilateral ACBD, if AC is equal to AD and AB bisects angle A, then the two triangles ABC and triangle ABD are congruent. So this was the proof of question number 1. Now let's take question number 2. And in question number 2, it's given that ABCD is a quadrilateral. So it's given that ABCD is a quadrilateral in which AD is equal to BC. It's given that AD is equal to BC. Also, angle DAB, that means this whole angle A, is equal to angle CBA, this angle B. Angle DAB is equal to angle CBA. Now we have to prove that triangle ABD is congruent to triangle BAC. Let's take these two triangles. So to prove, we have to prove that triangle ABD is congruent to triangle BAC. This is our first part. And in second part, we have to prove that BD is equal to AC. And in third part, we have to prove that angle ABD is equal to angle BAC. Now, in order to prove the first part, let's take the two triangles separately. Let's break the figure and we will try to make these two triangles separately so that we will get it easy. Let's make these figures separately. So here it is, triangle ABD, and the another triangle is ABC. It is given that AD is equal to BC. AD is equal to BC. So let's take these two triangles. In triangle ABD and triangle BAC, it's given that AD is equal to BC. Then it's also given that angle BAD is equal to ABC or CBA. Then it's given angle DAB is equal to angle CBA, and we can see that this AB is common in both the triangles. So side AB is equal to side AB, which is common in both the triangles. This, by using side angle side criteria, we can say that the two triangles are congruent. Therefore, triangle ABD is congruent to triangle BAC. We know that when two triangles are congruent, corresponding parts are equal. Since ABD is congruent to BAC, that means these two sides BD is equal to AC. It implies that BD is equal to AC CPCTC. Also, so here we got that BD is equal to AC. Also, we can say that angle ABD is equal to angle BAC, since these are also corresponding parts of these two congruent triangles. That is, angle ABD is equal to angle BAC. Thus, in this question, we proved that triangle ABD is congruent to angle BAC. Then, from these two triangles, we got that BD and AC are corresponding parts of these two triangles. So, we can say that BD is equal to AC. Similarly, this angle ABD and angle BAC, these are corresponding parts of these two triangles. So, these two angles are also equal. So, this was the proof of question number 2. Now, let's move to question number 3. In question number 3, it's given that AD and BC are equal perpendiculars to line segment AB. That means AD is equal to BC. So here it is given that AD is equal to BC. Also, it is said that these are perpendiculars. That means angle DAB is equal to angle CBA, and both are equal to 90 degrees. And then we have to prove, or we have to show, that this CD bisects AB. CD bisects AB means on intersection of CD with AB at this point O, this AB is divided into two equal parts. That means we have to show AO is equal to BO. Let's try to prove it. We will take these two triangles AOD and triangle AOD and triangle COB. We will take these two triangles AOD and COB. Here we can say that this angle 1 is equal to angle 2, as these are vertically opposite angles, and we know that vertically opposite angles are always equal. So these are vertically opposite angles. Then it's given that angle DAB is equal to CBA, or we can write angle DAO is equal to angle CBO, because both are equal to 90 degrees. And then it's given that this AD is equal to BC. So we got here by angle side criteria that the two triangles are congruent. Therefore, triangle AOD is congruent to triangle COB. AOD is congruent to triangle BOC. It means corresponding parts will be equal. That means AO is equal to BO. That is CD bisects AB. Hence, proved. So it was question number 3. Now let's move to question number 4. In question number 4, it's given that L and M are two parallel lines intersected by another pair of lines P and Q. So here L and M, L and M are two parallel lines and these are intersected by another pair of parallel lines P and Q. Now we have to prove that triangle ABC, so we'll join A with C as we have to prove that triangle ABC is congruent to triangle CDA. So it is given L is parallel to M and P is parallel to Q. So we are given this L is parallel to M, P is parallel to Q, and we have to prove that triangle ABC is congruent to triangle CDA. Now let's try to prove it. As we know that this L is parallel to M, since L is parallel to M and AC is transversal, therefore this angle 1 is equal to angle 2 because these are alternate interior angles. And we know that when two parallel lines are intersected by a transversal, alternate interior angles are equal. Similarly, this line P is parallel to Q and AC is transversal. Therefore, let's name this one as 3. Angle 3 is equal to angle 4. Again, alternate interior angles. Now, if we will take these two triangles, ABC and triangle ADC, in triangle ABC and triangle CDA, we got here that angle 3 is equal to angle 4. Prove it above. Similarly, this AC is common in both. So AC is equal to AC, which is common in both the triangles, and also this angle 2 is equal to angle 1, and we also proved it above. Thus we can say by angle side angle that the two triangles ABC and triangle CDA, these are congruent. And this was the proof of this question number 4. Now let's move to another question, which is question number 5. And in question number 5, we are given that line L is the bisector of angle A. That means here it divides angle A into two equal parts. So let's suppose the two parts as angle 1 and angle 2. And B is any point on this line L. Now, two perpendiculars BP and PQ are drawn from this point B on the arms of the angle A. Now we have to show that triangle APB is congruent to triangle AQB, and then we also have to prove that BP is equal to BQ. Let's write the given portion. So here it is given that L is bisector of angle A. That means it's given angle 1 is equal to angle 2. Also, BP and PQ are perpendiculars. That means angle APB is equal to angle AQB, and both are equal to 90 degrees. Now we have to prove, in the first part we have to prove that triangle APB is congruent to triangle AQB, and in second part we have to prove that BP is equal to BQ. That means B is equidistant from both the arms. Let's prove it. So here it's given that angle 1 is equal to angle 2 and angle AQB is equal to angle APB. So if we will take these two triangles APB and AQB in triangle APB and triangle AQB, it's given that angle 1 is equal to angle 2 given. Similarly, it's given that angle APB is equal to angle AQB as both are equal to 90 degrees, and then it's given that AB is equal to AB as it is common in both the triangles. Thus we can say by angle side criteria that the two triangles are congruent. Therefore triangle APB is congruent to triangle AQB, and since the triangles are congruent, then corresponding parts are equal. It implies that BP is equal to BQ. Thus, B is equidistant from both the arms of the angle. Hence, proved. So this was the solution or proof of question number 5. Let's move to another question, which is question number 6. And it says in figure 7.21, that's our given figure, AC is equal to AE. AC is equal to AE, and then it's also given that AB is equal to AD, and angle BAD is equal to angle EAC. Show that BC is equal to DE. Now we have to show that this BC is equal to DE. So we are given that AC is equal to AE. Also, it's given that AB is equal to AD, and it's given that angle BAD is equal to angle EAC, and we have to prove that BC is equal to DE. Now let's try to prove it. Here, if we will see that BD, this BC comes in the triangle ABC, and DE comes in the triangle ADE. So if we'll try to make these two triangles separately, one is ABC and another is ADE. And in these two triangles, it is given AB is equal to AD. Also, it is given AC is equal to AE. Now, we can prove that the two triangles are congruent if angle BAC is equal to angle DAE. But it is given that angle BAD is equal to angle EAC, which are the parts of angle BAC and angle DAE. So first we will try to prove that angle BAC is equal to angle DAE. Then it will be easier for us to prove that these two triangles are congruent. So let's name this as angle 1, or simply it is angle DAC. Now here it's given that angle BAD is equal to angle EAC, and if we will add this angle DAC on both the sides, BAD plus angle DAC, there won't be any change in the measures, as we know if equals are added to the equals, wholes are equal. So angle BAD plus DAC, BAD plus DAC, it becomes angle BAC is equal to, and here angle DAC plus angle CAE, angle EAC plus angle DAC. Then it becomes angle DAE. Now we proved that angle BAC is equal to DAE. Now we will take these two triangles. Now in triangle ABC and triangle ADE, it's given that AB is equal to AD. Also, we proved that angle BAC is equal to angle DAE, and it's also given that AC is equal to AE. Thus, by side angle side congruence criteria, the two triangles ABC and triangle ADE are congruent. And when two triangles are congruent, corresponding parts are equal. It implies that BC is equal to DE. Hence, proved. So it was the proof of question number 6, in which we proved that BC is equal to DE. Now let's take one more question, and that is question number 7. And in this question number 7, we are given that AB is a line segment and P is its midpoint. Since P is its midpoint, that means AP is equal to PB. So it's given that AP is equal to PB. D and E are pointers on the same side of AB. So these are on the same side of AB. That means either upwards or downwards. So here both are on the upward direction of AB. Such that angle BAD, angle BAD is equal to angle ABE. This one, angle 1 is equal to angle 2, and angle APE is equal to angle DPB. Now we have to prove that triangle DAP is congruent to triangle ABP. Let's make the two triangles separately. DAP and the other is EBP. It is given that AP is equal to PB. Similarly, angle A is equal to angle B. Now we can use the result of angle side angle, and then we can prove that the two triangles are congruent, and since if the two triangles are congruent, then corresponding parts are equal. So first we will try to prove that the two triangles are congruent. So for that it is given that angle APE is equal to angle BPD. If you will add this angle APD to both, angle APE plus angle APD is equal to angle BPD plus angle APD. It implies that angle APE plus angle APD gives us the angle APD. So its angle APD is equal to angle BPD plus BPE gives us the angle BPE. Now if we look at these two triangles, we proved that angle APD is equal to angle BPE. So we can use the angle side angle criteria in these two triangles, and we can prove that these two triangles are congruent. So in triangle APD and triangle BPE, angle A is equal to angle B, it's given. Then AP is equal to PB, it's also given because P is midpoint of AB. And then we proved that angle APD is equal to angle BPE. Thus, by angle side angle criteria, we can say that the two triangles are congruent. Therefore, triangle APD or DAP is congruent to triangle ABP. And since the two triangles are congruent, then the corresponding parts are equal. Therefore, AD is equal to BE. Hence, proved. So this was the proof of question number 7. Now we have one more question, and that's question number 8. And it is said in this question number 8 that in right triangle ABC, so it is given that this triangle ABC is a right angular triangle and it is right angled at C. That means it's given that angle ACB is equal to 90 degrees. M is midpoint of hypotenuse. M is midpoint of hypotenuse, that is AM is equal to MB. And then this C is joined to M and produced to D such that CM is equal to MD. CM is equal to MD and point D is joined to point B. Now we have to prove these four parts. Now let's take these four parts one by one. So to prove, in the first part we have to prove triangle AMC is congruent to triangle BMD. Now let's try to prove this first part. Okay, so here if we will take these two triangles AMC and triangle BMD, in triangle AMC and triangle BMD, it is given that AM is equal to MB, as M is midpoint of AB, so it is given. Then we can see that this angle 1 is equal to angle 2, as these are vertically opposite angles. So angle 1 is equal to angle 2, vertically opposite angles. Then this CM is equal to MD. Thus, by side angle side congruence criteria, the two triangles are congruent. Therefore, triangle AMC is congruent to triangle is congruent to triangle BMD. Since the two triangles are congruent, we can simply say that this angle, it implies that angle BAC is equal to angle ABD. So we got this statement from these two triangles. Since the two triangles are congruent, that means angle BAC is equal to angle ABD, because these are corresponding parts of congruent triangles. Now, in the second part, we have to prove angle DBC is a right angle. So, in the second part, we have to prove angle DBC is a right angle. That means angle DBC is equal to 90 degrees. So here, let's try to prove it. Since we got it that angle BAC is equal to angle ABD, angle BAC is equal to angle ABC, and if we will see, these are two alternate interior angles which are alternate interior angles formed by transversal AB with line is AC and DB. And we know that if alternate interior angles are equal, then the lines are parallel. Therefore, we can say AC is parallel to BD. Since alternate interior angles here are equal and these alternate interior angles are formed with line is AC and DB, therefore AC is parallel to DB. Now, AC is parallel to DB, or we can say BD, and if we'll consider BC as transversal, Therefore, this angle DBC and angle ACB, these are co-interior angles. Angle DBC plus angle ACB is equal to 180 degrees because co-interior angles are supplementary. So it implies that angle DBC plus, since it is given, angle ACB is a right angle, plus 90 degrees is equal to 180 degree. So it implies that angle DBC is equal to 90 degrees, because on transposing 90 to the other side, we will get that angle DBC is equal to 180 minus 90 degree. Thus we proved here that angle DBC is 90 degrees. So we proved the two parts of this question. Now in our third part we have to prove that triangle DBC is congruent to triangle ACB. Now let's try to prove it. So in part third, we have to prove triangle DBC is congruent to triangle ACB.